Okay, this is help with chapter 3, 3.3.20, and we are being asked to calculate the coefficient of variation for each data set. And we want our coefficient of variation to be rounded to one decimal place, but we need to look at our example to see what we want. The coefficient of variation is the standard deviation divided by the mean of the sample times 100. So we need to look at the steps here, and it looks like that to calculate the mean, we're going to round to one decimal place. But then if we keep looking down, to calculate the standard deviation, it says to round the standard deviation to 2 decimal places. So it may have been a little bit misleading when it said round to 1 decimal place is needed, because technically when you're calculating the standard deviation, by looking at the example, we can see that we need to round to 2 decimal places. So let's, of course we can work this using technology, but I would like to go over how to use the formulas. So the first formula here is the coefficient of variation, which is the standard deviation divided by the sample mean times 100. So this looks pretty simple. The coefficient of variation looks pretty simple, but when you actually look at the standard deviation, it's a little bit more complicated than the coefficient of variation. And in order to calculate the standard deviation, you see that, and I see where I made an error here because I forgot to put the x bar, which is the mean. We have to find the mean first. So the formula for the mean is right here. And anytime you see x bar means the sample mean, always in a formula in statistics. So you might want to make a note that x bar always means the sample mean. So let's look at our formula here. So you see it looks like a little E. It's a symbol called sigma. So whenever you see the sigma notation, and you can write it as an E if you want to, it means to sum up. So we're going to sum up our values, and xi always means all of our values in our sample, and we're going to divide it by n, which is n is always going to be your sample size, however many you have in your sample size. So let's do that real quick. I believe the first mean you have is 2 plus 5 plus 3 plus 9 plus 6, and the sample size is 5 because you have 5 values, and you end up getting 25 over 5, which is 5. So that is for your first group, and I believe we call this set 1. So let's just go through set 1, and let's look at what we would do next for set 1. So now we need to find the standard deviation. So I will show you a different way to do this later on, but for now, let's list our x values, which are 2, 5, 3, 9, and 16. And what we want to do is, it says, if we look at our standard deviation here, we want to take each x value and subtract the mean and square it. So let's go ahead and do that. We're going to do we're going to do 2 minus, remember our mean is 5. So 2 minus 5 squared. And 5 minus 5 squared. 3 minus 5 squared. 9 minus 5 squared. And 16 minus 5 squared. So let's get those answers. So 2 minus 5 squared, that would be -3 squared. So anytime we square anything, it's going to end up being positive. 5 minus 5 squared would be 0. 3 minus 5 squared would be 4. 9 minus 5 squared would be 16. And 16 minus 5 squared would be 11. So we've done our xi minus our mean and squared it. So the difference between our data value and our mean squared. Now what we need to do is order of operations says we always do exponents. And then what we're going to do is add these up because we have to do the sum of these, and then we're going to divide it by n minus 1. So let's sum these up, and when you sum these up, I believe we got 2731. This should be 1 down here. Because this should be a 6, not a 16. I can't read my writing. So that's going to be 1. So that would make that 30. So this up here is a 6. So 30. So we've taken our sum of our difference between our x value and our mean squared. Now we're going to always take this number and we're going to divide it by n minus 1. Now we know n, remember our sample size, n is 5. So our sample size is 5, so we're going to do 30 divided by 5, which is 6. Don't forget we have to do n minus 1, so 5 minus 1 is 4, and we get 7.5. And then the last step is always going to be to take the square root when you're getting the standard deviation. And once you do that, you get 2.74. So now we have our mean, which is, let's do it in pink. And then we have our standard deviation. We're going to highlight it in yellow. And remember, we're going to round our standard deviation to the second decimal place. You're going to work it just like the example, whatever they round to in the example. So now we're ready to do what we were trying to do here. And so we're going to do our coefficient of variation, which is the standard deviation divided by the sample mean. And we're going to times that by 100. So when we do that, we're going to do 2.74 divided by 5 times 100. So 2.74 divided by 5 times 100, you're going to get 54.8%. Okay, and you're going to do the second one the same way for set 2. So when you try it, you should get, I believe you get the, let me look and see, 9 for the mean, and then the standard deviation should be 5.34. So see if you can get that. And for your coefficient of variation, you can do 5.34 divided by 9 times 100, and you should get 59.3% for the coefficient of variation. which one has more variability? The higher the coefficient of variation is, the more variability it would have. So your data set 2 has more variability because its coefficient of variation is greater. Since I have time, I'll show you how to get, let's see if I can pull this up real quick. So if you open in StatCrunch, I'm going to pause it for just a sec. Okay, so if you go to Stat, I believe you can do, let me try Summary Stats. And let's do, all we need is the mean. And press Control and standard deviation. Let's see if we can get it that way. Yeah, so remember we did get 5 and 9 for our mean, and our standard deviation is 2.74 and 5.34. So here's another way to work it. If you want to get practice working it by hand, because it shouldn't take too long to do that since we don't have that many numbers. And then check it using StatCrunch. Let me know if you have any questions.